Hey, welcome to math. We're going to be taking a look at piecewise functions today. Just a little look at it. It is the last section of chapter 4, so make sure you pay attention. There's going to be a few questions for you along the way. All right, we're going to start out by taking a look at a review question because they're very similar to an old problem that we did in section 3.1, and that's evaluating functions. So we need to remember how to evaluate a function. So if we were to evaluate the function f of x equals 4x plus 3 when x equals 6, what that means is you take 6 for x and you plug it into the equation where you see x, right? So in this case, we would say f of 6, right? Because that x is 6 is equal to 4 times, again, x is now 6, right? So 4 times 6 plus 3. So an evaluating problem means plug it in for x and then solve it out. So go ahead and solve that one out. 4 times 6 plus 3, it's a PEMDAS problem, and enter your answer when you're ready. So we'd multiply first. 4 times 6 is 24, and then add the 3 makes 27 as our answer there for evaluating when x equals 6. We're going to be doing a bunch of evaluating problems today, and so it's going to be one extra step of figuring out which of the equations to use. But once we figure out which equation to use, the process is going to go exactly like this, what I just did, which is a review of section 3.1. All right, so again, our big term today is piecewise function, and a piecewise function is defined by two or more equations where each piece of the graph is described by a different equation. All right, I'm going to take a look at just showing you what a piecewise function would look like with its graph right next to it so you can see the pieces, because I think you see the pieces easiest from the graph, even though that's not going to be our main focus for today. But for a piecewise function, it's going to have two pieces. So you can see instead of having just f of x equals like x plus 3 like we would have on the first one, we have f of x equals x plus 3. And we'd read this f of x equals x plus 3 when, so that comma is like a when x is less than 0. And f of x is equal to 2x minus 1 when x is greater than or equal to 0. So how we can kind of think of that is when x is less than 0, that's over here, right? And so this kind of piece of the graph here is corresponding to that equation, right? And then x greater than or equal to 0 is over here, and this piece of the graph is corresponding to this equation here, right? And so we call it piecewise, sometimes we'll call it piecewise continuous, because within each piece, the graph is continuous. I can draw it without picking up my pencil. But overall, there is a discontinuity there at x equals 0, right? And so that's why we call it a piecewise function. We're not going to deal much with the graphs today, but I just wanted to show you the graph up front because that is where the name piecewise comes from. All right, let's take a look at an example here. We're going to evaluate f of x when x is 2 and when x is 7 here. And so we have f of x, which is this big thing here. It's x plus 2 when x is less than or equal to 5, and 4x when x is greater than 5. And I'm going to do two evaluations here, so I'm going to kind of split my screen up. And I'm going to start by doing f of 2. And so f of 2, that means plug in 2 for x, right? So I'm going to take 2 for x. Now the tough part about doing these is figuring out which piece of the equation I'm going to use. Now I should be able to see I have 2. And 2 is going to fit into the category when x is less than or equal to 5, because 2 is less than or equal to 5. Later on when I have 7, that's bigger than 5, so I'm going to use the second piece. So that means I'm picking this equation, x plus 2. So for f of 2, I'm going to write down f of x equals x plus 2. And then I want f of 2, right? So I'm going to be plugging in 2 for x in both pieces. So f of 2 equals 2 plus 2. So if f of 2 equals 2 plus 2, solve that out and enter your answer when you're ready. So 2 plus 2 makes 4, right? So f of 2 would be equal to 4. So that would be my answer for part A, solving for f of 2, right? So for part B, f of 7, the difference here is now for 7, I'm dealing with the other piece, right? Because now 7 is greater than 5, so I'm going to be using the piece 4x, right? So I know I'm going to be using the piece f of x equals 4x when x is 7. So go ahead and plug in 7 as my input for x. Solve it out and enter your answer when you're ready. Good, so if we take a look at that one, f of 7 is 4 times 7, 28. So my output there would be f of 7 equals 28 for part B. All right, let's take a look at example 2 here. We're going to let f of x equal 5x minus 1 when x is less than 2 and x plus 3 when x is greater than or equal to 2. So we're going to evaluate this for both f of 1, so when x is 1, and f of 5, so when x is 5. Let's start out with part A, which is f of 1. Go ahead and evaluate that function for f of 1. So when x equals 1, find f of x and enter your answer when you're ready. All right, let's take a look at this first one, f of 1. I ended up picking this piece of the function because 1 is less than 2, right? So I ended up picking that piece of the function, and I plugged in 1 for x. 5 times 1 is 5, minus 1 makes 4. So my output would be 4 when evaluating the function f of x for x equal to 1. We're going to try one more, so part B, we're going to try evaluating f of 5. So go ahead and try to evaluate f of 5 and enter your answer when you're ready. All right, let's take a look at this one. I'm going to use that second piece, x plus 3 here. And when I worked that out, I plugged in 5 for x. And once I evaluated that, I get 8. So f of 5 equals 8 on this one. Hopefully that kind of covers it for section 4.7. Thanks for following along.